Hello friends, today is very important lecture of the Siemens PLC. In this lecture we will cover the basic tool of the PLC programming, bit logics. You can see this is the bit logic, and first one is normally open contact. You know well about this one. This is the same like other PLC, and this is a normally closed contact. So this is a one invert power flow. So we will start from this one, invert power flow. Actually this command will change your logic from yes to no, no to yes, 1 to 0, 0 to no, 0 to 1. So we will do practical, and this one is the invert power flow. Okay, this is a command. So we will take some one input, and let I 0.1, and one is output. Q 4.0. Okay. So I will use this command. This is the invert power flow. I will drag here, and you can see this is a symbol of the invert power flow. So I will download this one in PLC and go to simulation and run your PLC and go to your monitoring. Okay, and you can see this one, your input is off but your output is on, because this invert flow change your logic from 0 to 1. When I on this input, so this is a 1, so this is a 1. You can see when I on the input but your output is off due to this invert power flow. This is a invert logic. If your logic is on but your output is off. Okay, and next one is coil. Is the same like other PLC programming, and this one is the midline output. You can see this in this rung, you can use only one output. You cannot use the other output on same rung. You can see here, but by using midline output you can use two output in one rung. Let's start. We will insert, and this is the midline output. Okay, and you can see one input, and I will use I 0.0, 0. Sorry, 0, and one output same Q 4.1. Okay, and use branch, use one more output Q 4.2. This is a one way to use two output by one input. Okay, and I will insert one more, and this is the same midline output and same logic. I 0.2 is the one input and one output Q 4.1. Okay, so I will use one more output here, same rung, by using midline output. Okay, and use same Q 4.2. Okay, and download the program and go to monitoring on the your PLC, run the PLC. Okay, now you can see here this time your I 0.01 is off. When I will on this one, your both output is on. Okay, now I will on this input 0.2 and you can same way to output is on. So by using midline output you can close your complex programming into very simple way. In this we are using two rungs branches for on to into outputs. So by using midline output I can on the two output by input in same rung. Okay, so of your PLC of the monitoring. Okay, next one is set and reset. Is the same like other PLC. I will give the one demo. I insert one more input network and I will use one input I 0.3. Use some one output for this rung. Use set Q 4.5 and I will add one more insert network and one input I 0.4 and use the reset coil Q 4.5 same. Okay, and download the program and metering is on your run the your PLC. No, I will close all input. No, this one is the I03. When I on the I03 0.3 and you can see your output is set. When I close this one, automatic your input is off but your output is set. You can see this a green line. Okay, for reset this output you have to on I 0.4 input. So I will on this one and you can see no, this is a not set, this is a no reset. So this way you can set reset the your output by using set reset command coil. Stop the PLC and stop the monitoring. Now next one is the FlipFlop. This is the reset FlipFlop and this is the set FlipFlop. So first we start the set reset FlipFlop. I will add one more network and use set FlipFlop. Okay, and use any memory like M0.0. Okay, sorry 0.0. Okay, and one input like I 0.0, and in R use one more input zero point 0.1 or one output Q 4.0. Okay. FlipFlop same like set and reset command, but it has some priorities. Okay. So, I will show in logic and download the program, start the monitoring and start your PLC in run mode. Okay. When I on the input, and you can see your output is set, and I off the input I 0.01, your output is still in set. Okay. And when I on the reset 0.1, and you can see your output it reset, same like set and reset command. But when I on the input I 0.0 and I 0.1, and you can see the purity is reset, your output is reset, even your input set and reset both is on. You can see I 0.0 and I 0.1 both is on, but your output is reset because this flip-flop is, because your set reset flip-flop its purity has reset. When I off the reset, again your output is set. Okay. So, this way this is a flip-flop, and use other one. I add one insert and same like one input and one flip-flop. No, I will take reset set flip-flop. This is the other one. You can use the SR, this is the RS. So, input is I 0.0, this is the reset, and I 0.1. I use M 0.1 and output Q 4.1. Okay. You can see the difference between SR RS. In this block, S is in first and R is last, but in case R is first and S is last. Okay. So, this is a reset set flip-flop, and this is a set reset flip-flop, and you can see the difference between both. I will do practical. I stop the PLC, and now I download the program on the and go to the and now run the PLC. No, you can see this time you can see your both output is off, sorry, input is off. When I on the I0.0, your program, your Q 4.0 is set, but in this case it is a reset because its priority is reset. Okay. So, when I on the both inputs, and you can say its priority is set because both inputs on but RF on the output, but this is the of the output. This priority is reset and this priority is reset when your both input is on. Okay, this way you can use flip-flop. And next is the positive edge and this is the negative edge. So, in the same way other PLCs, I will insert and one input I 0.0 and Q 4.0 and use P positive RLO edge detection. Select this one and add this one. Okay. So, I will use here set, it will give you more clearance concept. I use Q 4.0. Use one more insert input I 0.1 and same set, like use one reset Q 4.0, same output but use negative RLO edge detection and give any like M0 and same M0.1. Okay. Now, I will stop the PLC and download the program and start the monitoring. Now, on the PLC, and you can see this time your both input is on. So, no start. When I on the input I 0.0, okay, your output is set because it is a positive edge. Okay. Now, I want to reset this coil. So, this is a negative. When I move this input from 1 to 0, then your coil will be reset. You can check. You can see I on the input from 0 to 1, your coil still on, is a set, you can see. Okay, it is still set, but I off the input I 0.1 from 1 to 0, then it automatically reset. This green show is a set, and when I move from 1 to 0, it is reset. So, this is a positive and negative like other PLC. So, same way you can use this one, is the same work like this P and N. This is the address negative edge detection and this is the address positive edge detection, but in this case you will use a block. I give the example. I stop the monitoring and off the PLC, stop the PLC and add the one inserted run and when I add the same like this one, but it is in block form. Okay, for any question in this lecture you can raise the question in comment box. Our team will be give the answer of your question. Okay, bye.